Assalamu alaikum, dear students. You all know that we have already started the unit called as magnetic effects of electric current, and today we are going to share the answers of its textbook questions. First question is at page number 66. The question is: consider a circular loop of wire lying in a plane of the table. Let the current pass through the loop clockwise. Apply right hand thumb rule to find out the direction of the magnetic field inside and outside the loop. So first I have to consider this is my circular loop. This is my circular loop in which it is being given that the direction of current is clockwise. So the direction of current is such that it enters here and leaves in this direction. So the current moves in this direction. So it is categorically, or it is clearly shown that it is clockwise. Now we are supposed to find the direction of the magnetic field lines inside and outside the loop. In order to draw these magnetic field lines, what I am doing, I am using this right hand thumb rule, which you already know that it can be used to find the direction of the magnetic field lines. Here the thumb you have to hold the current carrying conductor such that the thumb points in the direction of the magnetic field lines. Then here when I will hold this current carrying conductor in my right hand, the thumb points in the direction of then here the magnetic field line inside the loop moves inwards and outside the loop they move outwards. So I have drawn for this portion, I have to hold it in this direction because the current moves in the downward direction. I will say here it is downward in the plane. So the magnetic field line, they are moving actually in this direction. You already know that the magnetic field line and the current carrying conductor, they both are at right angles to each other. So these are the magnetic field lines drawn for a current carrying circular wire. Now question number second, it is the magnetic field in a given region is uniform. Draw a diagram to represent it. Simply, you should, we have already gone through this term as well. When the magnetic field is uniform, it is always represented by a set of equidistant parallel lines, and these are the equidistant parallel lines which are used to represent a uniform magnetic field. And we know uniform magnetic field means when the strength or magnitude and the direction of the field at different points is same, we call that as uniform magnetic field. So this is the answer for this very question. Now question number 3 is choose the correct option. The magnetic field inside a long solenoid carrying current is A part 0, decreases as we move towards, and C part increases as we move towards, and D part is same at all points. So in case of a solenoid, we have already said that for a solenoid, the magnetic field in the core of the solenoid, we always assume it is uniform. It is uniform. That means it is same at all the points. D part. The answer is D part. It's same at all the points. Okay. Now page number 68. Sorry, it is page number 68. First question is, which of the following properties a proton can change while it moves freely in a magnetic field? There, it is given that there may be more than one correct answer. It is mass, speed, velocity, momentum. Now, you already know that when a charged particle moves freely in a magnetic field, it is acted upon a force. Since force can change, if force will change the velocity, and once the velocity changes, you will automatically state that the momentum will already change, because momentum is also changed whenever the velocity changes. So for this question, the answer is C part velocity and D part momentum. It is C part velocity and D part momentum. Question number 2, it is in activity shown, how do you think the displacement of rod AB will be affected if the current in the rod AB is increased? B part, a strong horseshoe magnet is used. C part, length of the rod AB is increased. So since we know that when a current carrying conductor is put in a magnetic field, it is acted by upon a force. That force is always given by I into L cross B. Force acting on a current carrying conductor in a magnetic field is always given by F is equal to I into L cross B, which means that A part states that if the current in the rod is increased, so F is directly proportional to I, which means that when the current in the conductor is increased or the current in the rod is increased, the force will automatically increase. I have written that, which means increase in current in the rod will increase displacement in the rod. Second part, a strong horseshoe magnet is used. Again, when you increase force directly proportional to magnetic field, when you increase the strength of the horseshoe magnet, that means the displacement in the rod will also increase. More the strength of the magnetic field, more will be the displacement in the rod. Third is the length of the rod. Again, force directly proportional length of the rod. More the length of the rod, more will be the displacement in the rod. Thank you.